Hello teachers and friends. Today our group will show you how to calculate the electric current and power from a circuit. We are given a circuit with two power supplies with three resistors and they are parallel to each other. R1 is 32 ohm, R2 is 41 ohm, and R3 is 78 ohm. The power supply DC 1 and 2 has electromotive forces 3 volts and 6 volts respectively. So first and foremost, we must determine the loops of the circuit. Draw the loops according to how you want it to be. The loops are decoded with red color. Next, we are going to determine the direction of the electric current according to the loops we have made. First, I1 goes out from the power supply and enters the junction with R2, then goes to the left. I2 goes out from the power supply and enters the junction with R2, then goes to the right. The middle junction is called I3, with I3 being the sum of I1 and I2. This is our first equation. Then we add points to make the drawing of the circuit easier to see. The next step is determining the equation from the journey of electric currents. Let's focus on loop 1. The journey is made from point A, B, D, and A. Since from point A to B the current flows through power supply, potential rise occurs and the E is positive. Next, it flows through resistors R2 and R1, which makes the delta V of BD and DA negative, because potential drop occurs. This equation is equal to 0. Delta V is I times R. Substitute the values of E and R to the equation. Then, we have the second equation. Next, let's look to loop 2. The journey is made from point C, B, D, and C. Since from point C to B the current flows through power supply, potential rise occurs and the E is positive. Next, it flows through resistors R2 and R3, which makes the delta V of BD and DC negative, because potential drop occurs. This equation is equal to 0. Delta V is once again I times R, and substitute the value of E on R to the equation. And now we have the third equation with a total of 3 equations with 3 variables. From here, we change the first equation in terms of I1, which equals to I3 minus I2. Then, substitute it to the second equation. Now, we have 2 equations with 2 variables left. Multiply the first equation with 78 and the second equation with 32 to receive the equal value of I2. Then, eliminate the I2 and we will have the value of I3, which is 0.061 amperes. Then, we substitute the value of I3 to the equations. From the first equation, the I2 value obtained is 0.045 amperes. Then, Substitute the value of I3 to the second equation, and the I1 value of 0.016 amperes is obtained. Now, we will count the voltage in R1. Use the formula V equals to I times R, and the V at R1 is 0.512 volts, the V at R2 is 2.501 volts, and the V at R3 is 3.51 volts. Lastly, we will count the powers in each resistor by using the formula P equals to V times I. Thus, the V at R1 is 8.192 times 10 to the power of minus 3 watts. The V at R2 is 0.513 watts, and the V at R3 is 0.518 watts. Our group consists of Angraini Alfina, absent number 4, Anthony Alden, absent number 5, and Ashley, absent number 6, from 12 Science 5. Thank you for watching our video, and we hope that our video will become helpful for your education in the future. Thank you!